Virtual Math with Mr. Ferrara. Hey, what's up everybody? Today we're going to be doing section 11.3, volume of pyramids and cones. Before we get into the volume, let's talk about Euler's formula. Euler's formula is a formula that relates the number of faces, vertices, and edges in a polygon. It says that faces plus vertices will always equal the number of edges plus 2. F plus V equals E plus 2. Number of faces plus the number of vertices equals the number of edges plus 2. Now, using Euler's formula, if we look at this cube, this rectangular prism on the right, we can look at the number of faces first. Faces are the flat sides of a three-dimensional shape. So if you look at the cube, the front is 1 face, the back is 2. The right is 3, the left is 4, the top face is 5, and the bottom face is 6. This shape has 6 faces. Now, vertices are the corners within that shape. This shape has 1, 2, 3, 4, 5, 6, 7, 8 vertices, 8 corners in a rectangular prism. Finally, if we did the math, F plus V equals 14, that would make me think that there should be 12 edges because 12 plus 2 is also 14. Edges are the places where the faces meet. If you look in this shape, there are many edges in that shape. To be exact, there are 12 edges in that shape, which does justify our formula F plus V equals E plus 2. In this shape, 6 plus 8 does equal 12 plus 2. That's Euler's formula. Now, to get started with volume, we're going to start with the shape pyramid. A pyramid is a polyhedron in which one face can be any polygon, and then all the other faces are triangles. The formula is 1/3 area of the base times the height. The shape of the base will determine which formula you use for big B, multiply it by h, and then do 1/3 divided by 3, or multiply by 1/3. Now, there is a difference between slant height and actual height. Slant height is as if you were standing on top of that pyramid and tumbled down the side. Slant height is represented by a script L. Slant height is not the height that we use in the volume formula. The height that we use in the volume formula is as if you were standing on top of the pyramid and fell straight through, straight down to the bottom, making a right angle with the base.
All right, let's look at some examples of finding volume of pyramids and cones. First one is find the volume of a square pyramid. The way I know it's a square is because the base is a square and the directions tell me it's a square base. So the formula for a pyramid is volume equals 1/3 big BH. The big B will change depending on what the shape of the base is. In this case, it's a square, so it's 1/3. Area of the base would be 15 times 15 since both of these sides are the same. It's a square. And the height is 22. The height is if you're standing at the top and you fall straight through into the middle of the pyramid. Multiply this out, 1/3. 15 times 15 is 225. 225 times 22 is 4,950. 1/3 of 4,950 is 1,650 centimeters cubed. The volume will always be in cubic measurements because there's a length, a width, and a height. There's the work for the first one. Pretty basic problem, not too bad. Problem 2 is taking that square pyramid and adding a little bit of extra to it. 16 is the one side, which means all sides are 16. But that doesn't help us find the height. We need to find the height from the top to the center of the pyramid. They only give us the slant height. Slant height is as if you stood on the top of the pyramid and tumbled down the side of it. So if you tumble down the side of the pyramid, it's 17 feet long. We need to use Pythagorean theorem in order to find h. H squared plus 8 squared equals 17 squared. That'll help us find the actual height, not the slant height. H squared plus 64 equals 289. Subtract 64 means that h squared is 225, and the square root of 225 is 15, which means that the height is 15. I now have enough information to find the volume. 1/3 big BH, 1/3, both sides are 16, so the area of the base is 16 times 16, and the height of that pyramid, which we just found, was 15. 16 times 16 is 256. 256 times 15 is 3,840, and I need to take 1/3 of that. 1/3 of 3,840 is 1,280 feet cubed. There's the volume of that second square pyramid. Now the third problem is not a square pyramid anymore. It's a hexagonal pyramid, which means the base is in the shape of a hexagon. A reminder, a hexagon is 6 sides. Find the volume of the hexagonal pyramid with a height of 10, not drawn in there, would look very messy, and a base edge of 10. Well, we need to review. How do you find the area of a hexagon? There's only one way that we can do that, and that's with our 1/2 apothem perimeter. So we need to find the area of the base, the hexagon, with a 1/2 apothem perimeter. Now I'm going to draw in our apothem triangle. If you remember, there's always 6 equilateral or an isosceles triangle, depending on the shape, on the bottom base. I draw in the apothem, and it makes a right angle. I'm going to take this triangle, and I'm going to draw it over here. This whole side is 10, which means this piece is 5. This angle up top, this whole thing, is 360 degrees divided by the 6 wedges, which means it's 60 degrees. This wedge is half of that, which means that angle is 30 degrees, which makes this angle 60 degrees. So if you want to use your special right triangles in this problem, 5 is the short leg, which means the long leg is 5√3. We could change that to a decimal, but I try to avoid using decimals as much as I can because you lose some of the value. You have to estimate 5√3 and you lose some of the value. So now it's 1/2. The apothem was 5√3, and the perimeter of the base, the perimeter of that hexagon, is 6 sides, each being 10. So the perimeter is 60. 1/2, 5√3 times 60. 60 times 5 is 300. Half of 300 is 150√3. That's the area of the base. That's big B. Well, now I want to go into the volume. The volume is 1/3 big B H. So the volume is 1/3. Big B was 150√3. And the height they told us in the beginning was 8. Now I need to multiply that together. I know that 150 times √3, now is when we might as well multiply it by a radical, times 8 divided by 3. When I multiply all that together and then divide by 3, I get the volume to be 692.8. So there's the volume of the hexagonal pyramid.
Cone is a pointed shape like a pyramid, but it's got a base that's a circle. The volume formula for a cone is the same as a pyramid, 1/3 area of the base times the height. However, if you go further, the volume would be 1/3 pi r squared h, pi r squared being the area of a circle, h being the height of the cone. Volume equals 1/3 pi r squared h.
All right, now we're on to cone problems. Cones are the same way, same formula as a pyramid. It's just they have round bases, so the big B is going to be a little bit different. So I got a cone here, and I want to find the volume. Volume still is 1/3 big BH. And in this case, the big B in a cone is always going to be pi r squared. So if you want to write it as 1/3 pi r squared h, you can also write it that way. I'm going to leave this in terms of pi in the beginning, just because I like to keep it in terms of pi. I don't like to estimate until the very end of the problem. 1/3 pi. The diameter is 6, which means the radius is 3 squared, and the height is 11. 3 squared is 9. 9 times 11 is 99. So this is 99. 1/3 of 99 means 99 divided by 3, which means I have 33 pi. So if you wanted to leave the volume in terms of pi, you get 33 pi. If you want to multiply it out, don't use the pi button for our assignments, use 3.14. So 33 times 3.14 gives us an answer of 103.6 feet cubed. That is the volume, not in terms of pi. Now the last problem, they give us the volume as 110 pi. We need to work backwards to try and find the radius. They give us a height of 10. So I'm going to write the volume formula down. Volume equals 1/3 big BH, which is 1/3 pi r squared h. I'm going to plug in what I know. I know that the volume is 110 pi, and that equals 1/3 pi. The radius squared I don't know, and the height is 10. I'm going to get rid of pi immediately. When you have pi on both sides, you can immediately get rid of them. You're dividing both sides by pi. So I'm going to get rid of it. Now I'm also going to divide by 10 over here, and I'm going to divide by 10 over here. 110 divided by 10 is 11 equals 1/3 r squared. We've already made it a lot easier. So this 1/3, that can move to the other side by multiplying by 3. 1/3 times 3 is 1. So if I multiply one side by 3, I multiply this other side by 3. 3 times 11 is 33 equals r squared. 33 equals r squared. Let's square root 33 to finish the problem. That means the radius is 5.7. 5.7 is the answer to problem number 5. If you have any questions on today's assignment, please feel free to Schoology message me, email me, call the Google helpline, or ask your questions during our next live conference. Till next time, bye.